Now here's a formula I've never seen on the IB test, but here it is. Let's get it. Right. This is our change in temperature, right? And this is the incoming radiation. That's the outgoing radiation. So if we've got like a surface here, right? The surface has a certain temperature and it's sending radiation up there, and this radiation would be related to the previous formula that we just did with radiative, right? And then we've got like the atmosphere here, and the atmosphere is sending radiation down there, and this is watts per square meter, right? And then remember that this surface heat capacity is joules needed to raise a square meter 1 degree Celsius, right? So if you multiply intensity by time, you get not watts per square meter, but joules per square meter, right? And then, of course, we're using, I don't know, some formula that, what is it, the change, the Q is, what was it, Q is area times CS times delta T, right, is basically what we're doing, right? Okay. Yeah, okay. So let's go ahead and just use this one here. Surface absorbs at 350 but radiates at that, right? And then we want to solve for C if it raises 0.2 in a half an hour, right? And then, let's see, we want to find the CS, right? Okay, so delta T equals I in minus I out times the time, right, over CS. And of course, CS is going to equal in minus I out delta T over the change in temperature, right? Right, so it's going to be parentheses 350 watts per square meter, right, minus 120 watts per square meter, right? And then our change in time is a half hour, so that's how many seconds? 1800 seconds, right? And then let's see, change in temperature is 0.2, and that's degrees Celsius, right? Okay, and then the reason that this ends up having the right units of joules per square meter degrees Celsius is that a watt is a joule per second, right, per square meter, right? And then here we're multiplying by seconds. That's supposed to be an S, right? And then so we'll end up in the numerator of this thing with actually joules per square meter, right? And then divided by degrees Celsius, and then you end up with that, right? Okay, so let's just do the math here. Parentheses, whoops, turn the calculator on. Parentheses 350 minus 120, right parenthesis, times 1800 divided by 0.2. And I get 207 and then 4 zeros. 1, 2. So let's see, 1, 2, 3, 4, 5, 6. All right, joules per square meter Kelvin. I would say degrees Celsius. I don't think that's right. But anyway, yeah. I think maybe in their textbook they say kelvins, but I don't think that's right. Okay.